Hello everybody, my name's Dave, thanks for joining me, and today we're going to do something that's a bit controversial. And it may not sound controversial at first, but I can assure you it's going to be. This is a history of bolts and threads as interestingly as I can make it. Now the history part is dead easy. It's really quite interesting if you're into that sort of thing. It doesn't go on for very long. However, when we get to the theory of the difference between a nut and a bolt and a screw, it gets quite controversial there. And no fault of mine. I totally believe what I read until I looked a bit deeper into it and thought back about my apprenticeship days. Anyway, let's go. So first, threads and bolts. Amazingly, threads can be traced back to 400 BCE. But the humble nut and bolt has different origins. Now, there's a man called Frederick E. Graves, and he says that the bolt has its origins in the 15th century. The conclusion is based upon the first printed record of screws appearing in a book from the earlier 15th century. However, there are records of unthreaded bolts being used by the Roman Empire. They soldered wire on to make threads, and the bolts were generally made from bronze. They used them in great presses, olive presses, things like that. However, according to old bolt expert Bill Eccles, good old Yorkshire names these, the history goes back even further. Archimedes between 212 and 287 BCE developed the Archimedes screw to raise water. However, there is evidence to suggest that the screw was used in Egypt way before the time of Archimedes, so he maybe didn't invent it. However, it is widely accepted that the screw was invented in 400 BCE. That said, the first ever industrial production of bolts was with a machine made by Bresson in France in 1568. They later brought out a screw cutting gauge or a plate to be used on lathes. In 1641, an English firm, Hindley of York, improved the device and it became widely used. In 1760, a company called J&W Wyatt introduced a factory process for the mass production of screw threads. However, this led to big problems, where each company manufactured its own version of screw thread, creating a huge range of different threads on the market. And so you couldn't make a nut here and a bolt there and they would screw together. They just weren't the same. So in 1841, Joseph Whitworth came along and managed to find a solution to this debacle. After many years of research and collecting samples from different workshops, he suggested standardising threads in Britain. For example, it was so that someone in Scotland could make a nut and it would fit a bolt that was made in England. He suggested that the thread angle should be 55 degrees and the thread pitch would be dictated by the bolt diameter. So the thicker the diameter, the longer the pitch. The shorter the pitch, sorry. In 1864, William Sellers proposed a 60-degree thread form. Had to be an American. And various thread pitches for different diameters. This developed into the American coarse standard coarse and the American standard fine series of threads. One advantage of the Americans had over the British was that their thread form had flat roots and crests. That made it easier to manufacture than the Whitworth standard, which had rounded roots and crests. However, it was found later on that the Whitworth thread form performed better in dynamic applications, and the rounded root of the Whitworth thread improved fatigue performance. During World War I, the lack of consistency between screw threads in different countries became a huge obstacle for the war effort. During World War II, it became an even bigger problem for the Allied forces. In 1948, Britain, the USA and Canada agreed on a unified thread for all countries that used imperial measurements. Unified fine, unified coarse. It uses a similar profile as the DIN metric thread previously developed in Germany in 1919. This was a combination of the best of the Whitworth threads form, the rounded root to improve fatigue performance, the Sellers thread, the 60 degrees flank angle and flat crests, However, the larger root radius of the unified thread proved advantageous over the DIN metric profile. And this led to the isometric thread, which is used in all industrialised countries today, apart from America. The difference between bolts and screws. This is where it gets a little bit controversial. Now, the American Machinery's Handbook explains that the bolts used to assemble unthreaded objects, typically with the use of nuts and washers. In comparison, screws are used to assemble objects with threads. That can be a thread that's already in an object, or it can cut its own thread. But the terms are often used interchangeably, and there's indeed a technical difference between bolts and screws. So what is it? What makes a bolt and a screw a screw? The size of the fastener has nothing to do with being a bolt or a screw. Oftentimes we'll look at a large fastener and want to call it a bolt, and then likewise we'll look at a smaller fastener and want to call it a screw. A lot of people think if you have used a wrench to drive it in, then it's a bolt, and if it's used a screwdriver, then it is a screw. Neither are correct. So what makes a screw and a bolt? It's the thread type. The difference between a bolt and a screw has nothing to do with whether it is a wrench or used to drive it in or how big it might be, but everything to do with the threads on the fastener. Screws are generally threaded all the way up to the head, whereas bolts have an unthreaded section. So here is a bolt, a washer and a nut, and here is a screw. Well, there's various screws. Some are like this one, and these are also screws. They're threaded all the way to the top. Machine screws. So what are the advantages of using a bolt instead of a screw? Well, a bolt does have greater holding strength, and so if its strength is a concern, a bolt is superior in that regard. So you put a bowl through a hole, put a nut and washer on the bottom, and that is what will make it stronger. However, a small bolt will never be as strong as a big screw. So it's all relative. It is easier to use locking devices like nylon nuts or split pins with castellated nuts and lock bolts in place. So you can push that through and a nylon nut on the end, or you can put a hole through it and use a split pin and a castellated nut, or you could use a spring washer, etc., etc. Another advantage is the ease of removal later on down the line. Nuts can be undone and redone, but screw threads will damage wood, plastics and other soft metals over time, and they may not hold up well to several reinstallations of a screw. But a bolt can be used over and over with no ill effects, provided that the locking mechanism is checked and changed if required. So basically, if you use a nylon nut on a bolt and you take it off, you need to put a new nylon nut on. Or if you take a spring washer off and the spring washer is flat, you need a new spring washer. So what are the advantages of using a screw instead of a bolt? Despite bolts being stronger, maybe, screws do have their place and do have advantages. Sometimes it's not practical to access both sides of a fastener or have it sticking through the other side. A screw can be driven in from just one side of your project. As an example, this is a cylinder head bolt. Now we've just discovered that cylinder head bolts are actually screws, because if we follow that definition, that is a screw because it's going into a predetermined screw thread and it's holding down the cylinder head. We have just discovered that cylinder head bolts are actually screws. Is this explanation correct? I typed a question into the internet as follows: is a cylinder head bolt a screw? And the answer came back was, a cylinder head bolt is not typically classified as a screw. It is more accurately described as a bolt. The distinction lies with their design and application. So they're going against the definition here. A bolt is generally used with a nut to secure two or more parts, correct? While a screw is designed to be threaded into a tapped or pre-drilled hole, which is what a cylinder head is. Cylinder head bolts are specifically engineered to withstand high pressures or temperatures. Now, it never mentioned high pressures or temperatures. So, is this correct or is it not correct? Well, I say bullshit to that. So that turns the previous theory on its head. So is it a screw or is it a bolt? Well, I looked at the Machinery Handbook and discovered the origin is New York. So it discounts any source of any data because it's American. Then I searched YouTube and found that the vast majority were American and mainly incorrect. The ones that weren't American were also incorrect. Here's my take on this. In 1975, I started an engineering apprenticeship. 1975, that's 50 years ago. Our instructors both had many years of experience. Both of them always said that if they had thread all the way up to the head, it is a screw, like so. And if there's a gap, like so, it is a bolt. Regardless of head types or how they were driven in, it does not matter. This fits with the head bolt theory. That's a bolt, a head bolt, and not what appears to be in the USA theory today. I'm not 100% certain it was right. They change names and call things by incorrect names, and I can see why it might change and be wrong. My instructors were both in their 60s, and in 1975 that means they were both born in the earlier 20th century. I believe that what they said to be fact, and I had no need to doubt them. They'll both be dead now anyway, so. Multiple applications. So there are many different applications and a lot of examples where screws or bolts work better. Therefore, the idea is to use them in many differing applications to suit every circumstance. However, that does not explain why there are so many drive types. If you need a countersunk screw, then what does it matter what driver it uses as long as it's countersunk? Well, in some cases it does. So why do we have different head types of screw? Why do we have so many different types is because so many manufacturers have tried to better their competitors over the years. Some worked, some didn't. But they have all hung around because some work better in different situations than others. So let's look at the history of these heads. So slotted heads. They have been around since the beginning, however they are generally only 2 points of contact causing the blade to cam out. This really negates the use of power tools, rendering them too difficult to use. The looser the head, the less point of contact and the more likelihood of cam out and damaging the work. You've all done it, you screwed in a screw and it slipped out and scratched everything across the surface. So the next head to arrive on the scene after the slotted one was, no, you're wrong. It was the Robertson square drive screw invented in 1907 by Canadian Peter Limburner Robertson. The novel design has twice as many points of contact with 4. The Robertson driver also featured a tapered head. It has a tapered head which further improves the point of contact. The next head to arrive on the scene was, yes, of course it was the Phillips head. It was invented in 1935 by Henry Phillips. Made for the automobile manufacturers who needed screws that could take greater torque and provide tighter fastenings for their production lines. Ironically, there is a Phillips screw company that have never made a Phillips screw or screwdriver. However, please note that the Phillips is spelt differently. There's only one L in the Phillips, whereas there's 2 in the screw head. So the next head to arrive on the scene is controversial. It was either JIS, which is a Japanese industrial standard, or the Pozidriv, and as we don't have a date for the Japanese standard, we'll use the Pozidriv. The Pozidriv screw was patented in 1962 to be an improvement on the Phillips head screw and was designed to reduce cam out, especially when the tip of the driver was worn. It is not compatible with Phillips screwdrivers, and when seen together it becomes clear why not. Or you can see why it might work for some people. The next head is the JIS or Japanese Industrial Standard. It is also made to be an improvement on the Phillips head screw and address a number of shortcomings of the Phillips head. Offering better engagement, less cam out, evidence suggests that the JIS became before Pozidriv, but there is no exact date, so we'll take the date we have. I do have a JIS screw here. It is similar to the Phillips head, but is denoted by a dot on the head. Some other types of modern head is the torque. Screw head is a star-shaped recess, also known for its superior grip and its resistance to cam out. Torx heads are popular in industries where high torque is required, such as automotive and electronics manufacturing. Torx drivers come in different sizes, denoted by the letter T for Torx, followed by a number. Also note that this head has a pin in the centre and requires a tool with an appropriate hole. Some other types of modern head is the hex head or Allen socket. These screws have hexagonal recesses and are driven by a hexagonal Allen key. They are commonly used in situations where access is limited. I do have a hex head screw bolt here. That's a hexagonal headed bolt. as the key can be inserted at an angle, especially when used with a rounded driver. You can see there are many different heads, many are used in different situations, although their origins are mainly from improving what is already there, hence the Pozidriv and the JIS. With these improvements comes differing situations where these screws stand out and are better suited to be used. For example, high torque for the Torx drive and angular use for the hex head. There are so many different types of head out there, but these are just a few of the more commonly seen drivers for those screws. Thank you for watching and listening. I hope you've learned something. I would bet money that people did not know the difference between JIS, Phillips and Pozidriv heads, but now you do. And please like and subscribe, and I'll see you on the next one. Any comments, please put them below and I will address them as need be. Thank you very much. See ya. Bye now.